Imagine you are floating in space. Ahead of you is a giant black hole. You get a little too close. Would you be crushed instantly? Would you be stretched like a spaghetti? Or could you actually survive longer than you think? To answer that, we first need to understand how a black hole is born. And trust me, its story is far crazier than most people realize. Every black hole begins its life as a star. Not a normal star like our sun, a giant star. For millions of years, this star is fighting a battle. Gravity is trying to crush it inward. Meanwhile, nuclear reactions deep inside the star push outward. As long as these forces are balanced, the star survives. But eventually, the star runs out of fuel. And that's when everything changes. Without enough energy pushing outward, gravity wins. The star suddenly collapses under its own weight. And then boom, a massive explosion called a supernova lights up space. For a brief moment, it can outshine entire galaxies. But the explosion leaves something behind. Something so dense and powerful that not even light can escape. A black hole. Most people think black holes are giant cosmic vacuum cleaners that suck in everything around them. But that's not true. A black hole only becomes dangerous when you get too close. Around every black hole is an invisible boundary called the event horizon. Think of it as the universe's ultimate one-way door. Cross this line and there is no coming back. Not because there is a wall, not because something grabs you, but because gravity becomes so powerful that every possible path leads deeper inside. Even light, the fastest thing in the universe, cannot escape. At its very center is the singularity, the most mysterious place in the universe, where our laws of physics appear to break down completely. And if light can't get out, neither can you. So what would actually happen if you fell into one? The answer is far stranger than most science fiction movies. Surprisingly, you would not notice anything special at first, at least not immediately. But then gravity starts pulling harder on your feet than on your head. The difference keeps growing. Your body begins stretching longer and longer. Scientists call this spaghettification, because you would literally be stretched into something resembling spaghetti. Not the most heroic ending, but here's where things get even wider. To someone watching from far away, you would appear to slow down more and more, until it looks like you completely freeze at the edge of the black hole. But from your perspective, time feels normal. It's one of the strangest effects predicted by Einstein's theory of relativity. After forming, a black hole can spend billions of years growing. It pulls in gas, dust, stars, and sometimes even other black holes. The biggest ones become supermassive black holes. These monsters sit at the centers of galaxies, including our own Milky Way. Some are billions of times heavier than our sun. Imagine fitting that much mass into a region smaller than our solar system. And yet, despite their incredible power, black holes don't live forever. They have an ending too. In the 1970s, physicist Stephen Hawking discovered something shocking. Black holes slowly lose energy, little by little, over unimaginable lengths of time. This process is called Hawking radiation. Eventually, after trillions upon trillions of years, a black hole can completely disappear. That's right, the universe's most powerful object slowly evaporates away, which means black holes have a life cycle just like stars. They are born, they grow, and one day they die. But perhaps the strangest thing isn't the black holes exist. It's that the same laws of physics that created them also created you. And somewhere out there, right now, another giant star may already be beginning the journey toward becoming the next black hole.